In this problem, we're going to graph y equals sine of negative 2x using the 5 key point method. What we should notice right off the bat is that the argument of the sine function has a negative in it. Whenever the argument of a trigonometric function has a negative in it and you want to graph, what you should do is use the even-odd properties of that trigonometric function. For example, the sine function is an odd function, which means that the sine of negative theta equals negative sine theta. So I can rewrite sine of negative 2x as negative sine of 2x. Now I can see that the value of a is negative 1, so the amplitude is 1, which means this graph is going to oscillate between negative 1 and 1. And then I can also see that the value of omega is 2. That means that the period, which is 2 pi over omega, is going to be 2 pi over 2, or pi. Now, the graph of the sine function is going to begin at x equals 0 and end at x equals pi, because it takes pi units to draw one complete cycle of the graph, because the period of the function is pi units. What we're going to do is take the interval 0 to pi and divide it into 4 equal subintervals. Therefore, each subinterval is going to be of length pi over 4. So my first interval is going to correspond to from 0 to pi over 4. My next subinterval goes from pi over 4 to pi over 2. My next subinterval goes from pi over 2 to 3 pi over 4. And my last subinterval goes from 3 pi over 4 to pi. Now the endpoints of these intervals correspond to the x-coordinates that are the key points on the graph. So my key points are on the graph are going to be 0, comma something, pi over 4, comma something, pi over 2, comma something, 3 pi over 4, comma something, and finally pi, comma something. To understand what these y coordinates are going to be, we have to think about the graph of y equals sine of x. One cycle begins at 0, 0, therefore my first key point is going to be 0, 0. The next key point on y equals sine of x is pi over 2, comma 1. Well, with the y coordinate of 1, we then multiply that by the a in front of the sine function. So my key point on this graph is going to be pi over 4, comma negative 1. My next key point has a y coordinate of 0, so this is going to have a y coordinate of 0. My next key point on y equals sine of x is negative 1. Multiply that by this negative 1, and I get positive 1. And then finally I'm back to a y coordinate of 0. So I'm going to plot these key points in the Cartesian plane, which I draw now, using the fact that the period is pi radian. I can scale my horizontal axis appropriately. Pi over 4, pi over 2, 3 pi over 4, 4 pi over 4 or pi, 5 pi over 4, 6 pi over 4, or 3 pi over 2. And I can do that in the negative direction as well. Negative pi over 4, negative 2 pi over 4, or negative pi over 2, negative 3 pi over 4, negative pi. Then I'll scale my y-axis, label my y-axis, label my x-axis, plot these key points. 0, 0, pi over 4, comma negative 1, pi over 2, 0, 3 pi over 4, comma positive 1, and then back to pi 0. And then I sketch in my sine function. Now I can continue in this fashion. 5 pi over 4, comma negative 1, and then back to 3 pi over 2, comma 0, and continue. Or going in the negative direction, this point is going to be negative pi over 4, comma, positive 1, and then negative pi over 2, comma, 0, and continuing, I can trace in my sine curve. So this represents the graph of y equals sine of negative 2x.